Hi, I'd like to show a demonstration of some major enhancements to Illuminated Cloud support for code completion in Apex. Now, Illuminated Cloud has offered very robust support for code completion, not just in Apex, but in the Salesforce scripting languages, markup languages, query languages, since its introduction many years ago. In particular for Apex, it offers contextually aware code completion that uses both the point of insertion of a given code completion. For example, you would not expect to have a count offered because it's not been declared here, and it's not rightfully so, but string value 1 and 2 and string to integer and string to string map are because they've been declared already. But it also uses type inference, real-time expression type evaluation for every expression in the document and in the project in order to offer the correct completions based upon, for example, indexing into the members of another variable. So this is a string value 1 is a string type variable, and when I say dot, it's only showing the members of the string type that are available for completion. And that's true no matter how far you chain those. This type reference is used heavily throughout Illuminated Cloud to provide quite a few of its more advanced features. However, one thing that it doesn't do is traditionally is it doesn't check to see if an offered code completion is valid based upon data type agreement at the point of insertion. So for example, this method, string.indexOf, the first argument of it requires a string or something that can be assigned to a string. If I look for code completions here, it is offering me all the identifiers that are accessible from this point. But for example, if I choose date time value, Illuminated Cloud rightfully tells me it expected a type of string for the first parameter of index of. It found a variable of type date time. So there's a type mismatch, and that would not compile when this gets to the server. So there's certainly room for improvement there. The type of completion that's been offered so far is called basic completion, at least in the JetBrains parlance. And there are two other types of completion. This enhancement adds something called smart code completion. Smart code completion is activated by using Control-Shift-Space, whereas traditional code completion or basic code completion works either based on auto-completion or based on, for example, triggers like a dot in order to look at variants or members, or based on pressing Control Space. So for example, if I clear that and press Control Space, it will automatically activate completion. Smart code completion, like I said, uses Control-Shift-Space. It is not a replacement for basic, and I will show examples of this. They are intended to be used together. In situations where the expected data type can be inferred, you would use smart code completion, and in other situations you would use basic. And again, I believe examples will show this very well. So for example, in index of, if I use basic code completion, again, it shows me everything, and that's the last time that I'll do that. If I use smart code completion, Control-Shift-Space, it filters down to those that match or are assignable to the expected type at the point of insertion. So in this case, string. So it's showing me string value 1 and 2, and it's showing me a method toString. Similarly, if I go to the second argument, which is of type integer, it's an offset to begin the index of search, it shows me the variables that are assignable to type integer. Another example of this would be construction of an S object using the special constructor syntax that allows you to do field-wise value initialization. So each field has its own data type, and you should only be able to assign things to that field that are valid and assignable based on their own data type. If I use smart code completion, it will only show me string value things for account number. For number of employees, which is of type integer, it will only show me integer value things. For name, I used another string here because I want to show something else. String to string map is not actually of type string, so it wouldn't be offered, but that's not actually what I want to use to initialize name. I want to pull something from that map. So this is an example of wanting to use both basic completion, string to string map, and then we'll just clear this out, dot. And then right now it's showing everything but Control-Shift-Space, and it'll only show me the things that return type string that are members of map of string to string. So I will go ahead and say get, and now it requires an argument of type string, and I'll use smart completion, and we will key in by string value 1. And the next one is of type decimal. And one thing I want to show is that it's not strict type equivalence that it uses to determine which completions to show. It's the ability to assign. And there are rules for type conversion and type coercion in Apex, and it follows those when offering these. So for example, here it's going to show variables that are of type decimal, integer, because annual revenue is of type decimal. An integer can be safely assigned to a decimal, but not vice versa, because it would actually lose information about the decimal value by losing the fractional portion. But an integer can be safely assigned to a decimal. Similar in the math class, the utility methods, you have methods that return type double, long, decimal, integer, and all of those can be safely assigned to this field of type decimal. So as you can see, there's quite a bit of analysis going on to determine the correct subset of completions to be offered using smart completion. Another example, I've added in the past some live templates and things like that that assist with construction of what are otherwise tedious things to type. For example, new map in M, tab, and I'm going to say ID to account, and we'll just call that accounts by IDs, and it went ahead and created that for me, but that's very specific to that collection type and other collection types. If I wanted to create these same lines of code, I can say standard controller using basic completion, let it offer a variable name for me, equals new. Now I can use smart completion, and it will only show me the constructors that are inherently assignable to standard controller. In this case, there's one. And there is no default constructor for a standard controller, so it's telling me that's not defined. We can see that it requires an S object. I will use smart completion again, and it will show me the S objects that are available for completion. I'll just choose the account. And for the next one, shopping list mobile view controller, and I'm going to call this just controller. It's going to suggest a unique name, equals new. I'm going to use smart completion, and it'll just show me the one and only constructor for shopping list mobile list controller, sorry. And that actually requires nothing. And I meant to do, we'll just go ahead and say shopping list mobile view controller, and we'll call this controller 3 equals new. And this one actually does require a standard controller. There's only one on the stack right now, and it will automatically populate it for me. So you get the idea. There's another example of this that's interesting, and it has to do with inheritance hierarchies and polymorphic behavior. So this is a class with a very shallow inheritance hierarchy, and one of the prescribed best practices when you are coding against inheritance hierarchies is type your variables as the most general type that you can, and instantiate them as the most specific type that does the work you need it to do. So for example, if you've ever used Java, you know that you would declare a list as list of string, name it equals new, and then you would choose the concrete type of list, array list, linked list, whatever it happens to be, that supports your use case best. So similar here, we can say base class, my base class equals new, and when I use smart completion in order to bring up constructors, it will show me all accessible constructors that are assignable to base class. So that's going to be for each level in the type hierarchy. So we'll go ahead and say derived class, and that takes care of it. It makes it very easy to code against your type hierarchies. I'll go through a few other examples here rather quickly. So in this case, if I am trying to figure out the left-hand side as relational expression, I can pretty much insert anything. But once I've locked in on the left-hand side, using smart completion, it's only going to show me things that are valid for comparison, relational comparison against the left-hand side. Another very interesting example is picklist fields. Picklist fields in Salesforce have a constrained set of values, at least for a moment, ignoring the ability to add new values on the fly by saving objects that have fields with unknown values. And the values for picklist fields are known in the metadata. So for example, when the offline symbol table was generated, these were the values for this picklist field for store. You can see them right here. You can see the metadata about them, which one's active, things like that, or whether they're active, things like that. If I want to use one of those values, traditionally, I would have to type out the symbolic constant for it, basically the string literal. But with smart completion, Illuminated Cloud knows the left-hand side, it knows the field, it knows it's a picklist field, and it will actually offer the distinct values of that. And all you have to do is choose one of those, and it will insert the string literal effectively as a symbolic constant value for that. And you can see that below that, things that are also of type string are offered, but the the valid values from the metadata are prioritized first as valid completions. Sorry. Here is case.type. It's also a pick list field, has its own set of values, and you can see that both system fields and custom fields that are pick list fields get the same advantage when you use smart code completion. And this is not just in the constructor assignment, but really anytime you're assigning to one of these, you get the same feature. Collection initializers. Another example of a place where a data type is established contextually and can be inferred. In this case, a collection of S objects. Anything that's of type S object could be used in this initializer. Similar with strings. In the case of a map, it's a map of string to integer. So the keys must be strings and the values must be integers. Again, I'm using Control-Shift-Space each time that I do this to trigger smart completion versus basic completion. Query bind expressions. There are several places in SOQL that you can use bind expressions, and you can basically have the query use a value from the surrounding apex. For example, in the where clause relational expressions, you can do this. You can use it to establish limit and offset clauses. For relational expressions and where clauses, it uses the field on the left-hand side to constrain the value that is allowed on the right-hand side. For limit and offset, it is obviously going to be integers or things that are assignable to integers. For DML statements, it will only present you with individual S objects or lists of S objects. For creation of constructors, if you use it at the point where the constructor, for exceptions, if you use it at the point where the constructor for the exception would be referenced, it will only show you exception constructors. And of course, for return values, it will use the return type of the enclosing method. So in this case, S object, and only show you things that evaluate to S object. If I said support case dot and used smart completion, it would only show me the one-to-one relationships off of support case that are themselves S objects. And here's a void method, and you can see that smart completion says there's nothing because, of course, there is no ability to return a value. So this is smart code completion. I'm hoping you find this useful. I'm hoping that the relationship between basic code completion and smart code completion makes sense. If it doesn't, certainly let me know. One is not a replacement for the other. They're complementary to one another and support different use cases. Use smart code completion or basic code completion whenever you're using auto completion or when there's no inferred expected data type at the point of insertion. Use smart code completion when there is unexpected or inferred data type at the point of completion. And if you find any places where smart completion should work and doesn't, feel free to file a bug. If you find any place where smart completion is working but it's offering completions based on incorrect data types, please let me know that as well. Thank you very much for your time.